In this video, I want to talk about the bad surfaces and bad objects and how to replace a bad object and fix it to get better results and just better surfaces. So the first thing that I'm going to do with this object here is explode the object. This way we can select the different surfaces. And the first thing we're going to look at is the point layout for this surface. And as you can see, this surface looks really good, but it comes to a single point. So it makes a triangle, and so that tells me it's actually a three-sided surface. So it has one side here, a second side here, and then the third one just wraps around the entire thing. So ultimately it's a three-sided object, and a three-sided object is a bad object. So basically, to fix it, you have to discard this surface and build something else. So that's the first thing you need to know about building this type of object. Now there's two ways to do it. One would be replace the entire thing with one single surface, or you can reuse some of the edges that were used originally. So what I'm going to do here is I'm going to go under the curves and I'm going to duplicate the edge. So I'm going under curve from objects, duplicate edge. I'm going to duplicate this edge, press enter, duplicate this edge, press enter. I'm going to delete this surface here because we have these ones that we can use as a reference anyway. And yeah, okay, we've got everything we need. So for now, all I'm going to do is sweep. I'm just going to type it in, but you can go under surface, sweep one rail or two rails. In this case, we want one rail. Most of the time, I would just type it in, sweep one. And the rail is usually the largest one, so it would be this curve. The cross-section is usually the smaller one, so we'll use this one. Press enter. And so here you have a few different options. This doesn't matter because we're going to manipulate this surface anyway. We're going to make changes to it. So I'll just press OK. Now I'm going to look at the point layout so I can show the points. And I can see there's already some strange things happening. It doesn't need to have so many points. In fact, the less points you have, the better in this case. So the first thing I'm going to do is rebuild. I'm just going to type it in, rebuild the surface. And it looks like it's a degree-free surface. So instead of having 24 point count, I'm going to make it something like 5 or 6. Yeah, 6 should be good. So 6 and 4. And if you calculate, you can see there's a crazy number. This is actually very small because if I said 2, it would say actually 8. I'm not sure if it's actually simplifying the surface too much, but there's one way to find out, just commit to it. And if you don't like it, just go back, do a sweep one and go from there. It seems like it's going to do what we want it to do. So if I show the points, you can see that now it's a lot more simplified, it's a lot easier to work with. And actually it's not simple enough in my opinion because we want to pull this corner here upwards so it's flatter, and I don't think we're going to be able to do that with this surface as it is. It's just not going to be efficient for us to do it with so many points. So I'm going to go back and rebuild it one more time, and this time I'm going to rebuild it with let's see, we have 6 right now, so half as much. Something here we are using 2 degrees, so I'll use 2. I'm really simplifying the surface in a way that makes it easy for me to work with. Now keep in mind I'm using 2 degrees, and usually 2 degrees is not something that you want to work with. The reason why I'm saying that is because when you're rebuilding it for modeling purposes, just to go quickly and get some interesting results, it's actually really easy to model with 2 degrees. But when you're finished with the type of curvature or the type of form that you're looking for, then you'll have to crank up the number of degrees to something like 3. The reason why you want 3 degrees is because with 3 degrees, you can have better transitional surfaces. It just relates to the mathematics of the software. So I wouldn't worry about it too much at this point. So I'm just going to go in and refine this edge. One thing I want to be aware of is this point here. Obviously it cannot go above this point, because if it does, then it's going to go and create a weird kink in between this side of the surface and the other side of the next surface. But as long as we don't go past it, it should do the job and do what we want it to do. So that's basically what I would do: create a simple square surface and then go in, manipulate the points. Make sure you use a low number of points so it's easier for you to work with. And once you've got the results you're looking for, just go in and rebuild once more. And this time we want to make sure we're using 3 degrees on the U and the V. Here I'm using 4 because it says the V is 4 at this time. So if you see a higher number or a lower number, it doesn't really matter in this case actually. If I said 3, it would just give me a degree 3, which wouldn't be too bad. But I'm using the same count point on the V at this time. So it's just something to think about when you're changing degrees. You can look at the original degrees on the left, and then you can change them on the right side. So I'm just going to speed up the process, and you don't have to spend the time and watch me do it very slowly. So I'm going to speed up the speed of the actual video and just show you the final result. At this point, I've got the surfaces I want, and they're created with 4-sided surfaces. One thing I did here is I scaled some of these points from a location that was basically flush with the original surface, and on the other side it wasn't flush. So by scaling it in one dimension, I just kind of adjusted the surface and how it lines up with this other surface. That being said, this surface here is not perfectly flush with this one, so there is a small gap in between, and the way I would fix it in this particular case, just to go quicker and to make it work better, is by matching this surface to this one. Now the problem with this is that here you have 2 surfaces and here you have 1 surface, so it might be more difficult than expected. So if I think ahead of time, the best way to do this would have been to actually extend the surface further, make sure that they intersect, and if they intersect, then it wouldn't be a problem. So looking at it, we can see it's actually not really able to extend further. So maybe an easier way to do it would be to untrim everything. And we can use this surface here, and let's see how many points it has. We can rebuild it, and if we rebuild it on the left, it's going to tell us the number of points. So we can see it's actually a degree 2 surface, so that might be a problem. Let's make it a degree 3, and then let's keep everything as it is. Now, what I want to do here is extend this surface to this one. I know for a line you need another line, so I made the assumption that for a surface you would need another surface. I guess I was wrong, we can just use the factor, and I'm guessing that factor 1 would result in no change. And actually it did result in a change. Interesting. So yeah, if you do factor 1, it's going to increase by something, I guess 50% more, something like that. So it seems like I did not even need to create some kind of reference geometry. So I'm just going to go back and show everything, and we should be able to trim it. Yeah, that's it. So now looking at the geometry, you can see that you have enough points. It seems like we have 5 points, which is really good. And that's it. Yeah, that should do the job for us. So now we can actually make sure that this surface matches with, let's see what's going on here. Do we have something else? No. Okay, so I'm going to use the same process again. We're going to select these surfaces we're working with, and we're going to hide whatever we're not working with, because otherwise there's just too much to look at. Okay, so now we can match this surface to this surface and make sure you don't want to use average curve in this one, or average surface, and you want to make the first one tangent to the second one. Or curvature should also work because we have enough points to do that, and you can see how the surface is adjusting. So the first surface we selected is being aligned or matched to a curvature continuity to a reference geometry, which is the second surface we selected. So the first surface that we selected is becoming curvature to the second surface we selected. Now press OK. And we can finally use these surfaces to trim whatever extends past it. And then we can use the surfaces that we just cut, and we can use them to trim. And I'm just typing in the trim command, but you can go here if you want. There's always multiple ways to access different features. Personally, I like to type in all of my commands. And as you can see, it worked. So it gives us much better results, really clean surfaces. It allows us to have curvature in between the surfaces, and it gives us much better results. Yeah. Seems to be able to select it, but it's also recognizing a second edge, so I'm not sure if that's going to create some more problems. We definitely don't want it to be 1. 1 seems to be very large, so we'll try something like 0.1. And let's see if it works. Yeah, it doesn't work. So for some reason, when we extended the surface, it created 2 different surfaces. So it seems like all I had to do was untrim the surface, and it looks like it solved the problem I ran into. So not sure why this happened, but it seems like it created additional surfaces that we don't really need. And yeah, it complicates everything because now we have small surfaces in between. Maybe it was the option I used when I extended it. I saw that when you type in extend surface, when you extend it, you have 2 options. One is smooth and the other one is line. So I'm guessing that you have to use the smooth instead of the line. But I wouldn't worry about that. You just have to experiment with it, and it would have been fine to keep it sharp. I just want to show you that this allows you to have a lot more control with your fillets and radii and just keeping everything really, really smooth. But honestly, the previous result was much better, and it was already good enough for this particular surface. So anyway, once you have everything that you're working on, that you want for that surface, again, you can use this selection feature using the select object, and you can join everything. And now once everything is joined, you can use the fillet edge, select your edge, and it should be able to create a nice transitional surface. It seems like it's too small, so I'm going to undo that, go back, increase the size, and hopefully get even better results. And here we go. So now we have a nice transition in between, everything is really smooth. And if we look at the Analyze Surface zebra, you'll see that the continuity between your surfaces is very, very smooth. It's much better than it was before. Now, on the other side of this object, the same problem happened. So obviously, I'm not going to do the same process again. But as you can see, you could use the same method to resolve this issue. And one reason why I'm showing you this right now is because we can add this object to the zebra tool, and we can compare how you're getting these reflections and these breaks in between each of the sides. And if you look back at this side, you can see there is no break in between the surfaces, because they've all been aligned to each other